Wow, we got a whole crowd.
Yeah. Hey, Darren.
Hey,
Hi.
Hey,
okay. Um,
Aiden, welcome.
Hello, everyone.
Matthew. Michael, are you able to show your video?
Hey,
There you go.
there he
how's
is.
things?
All right.
List port.
Yeah, Michael, you better be here. You got me into this.
Hey,
Okay.
Eric, Bruce.
Oh, there's some people I recognize. Bruce McKenzie, David Chauvron.
Yep.
Is Bruce McKinsey here? I don't see him.
I
Yeah,
saw him
he's
right
here.
here. I see him. He's right next to Aiden. Bruce McKenzie is very clear.
Video's off, though.
I'm sorry. Do you guys see Bruce McKenzie?
Yeah, I see him.
I see his name. I don't know if I saw him in person.
Oh,
His
I'm
So
name's
sorry.
up
his
there.
Sorry.
video is off, and
I was
looks
debating
like
on the
he's not
video.
connected to
I
audio.
don't know how much bandwidth you have, so I'll just debating video or no.
I'm finishing up dinner, so I might just leave it off for a few minutes here when I finish.
It was Sean.
Is
Great.
that corn in your background, Bryce?
Of course. That would be much later in the season corn if I'm thinking that's the right background. Let's look.
Yeah, it's definitely end of season.
Oh yeah, yeah. That's like August, September corn, probably September.
Eric,
And you have a purple
Daniel.
onion behind that.
Yeah, Battlestar Galactica. It's supposed to be. I was trying to draw like a ceiling with the, like a space covered ceiling with the purple light, but didn't quite Photoshop its way in. All right, could just go with a regular field and just call it a day. Got plenty of those. Let's see, or I could go with something like this. Some people probably recognize where that's at. It's the same place as that.
Hey there, I just I'll be off video for the most part because I'm picking up some food for the family Sunday night, but I'll be listening attentively and then try to pay more attention or be more available towards the end.
Roger.
If anybody's been to the new NSS headquarters, this is the
Nice,
view out of the parking lot.
nice to see you, Eric. I'll talk to you later.
Wow.
I see Michael Lane. Hello. Don't see you too
Hello.
often.
No,
From Bruce
no.
McKenzie.
Nice to see you too.
And Dave Chevron and I just a few days ago went out to Goddard's house where he was born and lived when he was in Massachusetts. And
Nice.
it was a family home. It's 200 years old now. We're coming up in the 100th anniversary of his first liquid fuel launch. Over.
Wow.
Welcome, Sean.
It's hard to fathom that
But
before that there was no liquid rocket.
Yeah.
huh,
I mean, you had solid rockets going back to antiquity in China, but nobody had a liquid rocket up until Goddard.
Yep.
okay, I'm reaching out to a couple more people who said they're going to join us. Dave Huntsman, I believe. Daniel Tompkins. Sometimes people forget at the last minute, which I do myself.
Yeah, it's Sunday night. Happens.
Okay, I tell you what, we have maybe two or three more people that will be joining us, but I think for many of you, you may not know each other. Some of you know each other, but it's sort of a bit of a mixed organizational group here. So why don't we just take a moment and, just in less than 1 minute, I mean, like 30 seconds, just who you are, where you're from, and what you are known for. So I'll go ahead and start, and I'll go ahead and call out the names for you guys to introduce yourself. So Doug Plata, I'm the president and founder of the Space Development Network, a free to join forever group for space advocates. Meet together in these working groups, and we just seek to go ahead and advance the cause of space development as much as we can. So otherwise, I am a occupational medicine and urgent care physician in Southern California, Redlands, California. Matt, how about yourself?
Yeah, I'm a software network database admin. Live in California, San Francisco Bay Area. And have been following space stuff for almost as long as, at least since Apollo. And I'm still trying to find a way to get into space. My original career I planned was as an asteroid miner. That hasn't worked out, but I haven't given up the dream. So
Give it time, man. Aiden?
Hello, everyone. My name's Aiden. I am a mechanical engineering undergraduate student with the University of Buffalo, and I work on nanosatellites through research via my university.
Darren?
I'm an electrical engineer from Loma Linda.
Southern California, a friend of mine. Bryce?
Hi, I am I'm known for space farms. I'm the AIAA SS Space Settlement Tech Committee lead. I'm in NSS, do all kinds of stuff there. And my day job is somewhere between aerospace engineering, software engineering, cybersecurity, and AI.
Just to name a few. Jerry?
Yeah, just a little.
Hi, I'm a retired aerospace engineer. I'm 79 years old, so I first got enthused about the space program when Sputnik 1 was launched, and I did work on the Apollo a small amount. So I worked in the aerospace engineer for over 40 years.
And Jerry is our vice president for projects for the network. Bruce?
Right.
Hello, I'm Bruce McKenzie, live near Boston. Been very active in a number of space organizations, especially NSS, Mars Society. I founded the Mars Foundation. I design settlements for Mars, the architectural design, and also interested in using tethers to throw payloads around, and also, a lot of things that get people into space. Doug and I have been working together fairly closely. What is really hot on my mind now is to build a combination visitor center and analog base. Over.
And Bruce is the general vice president for our network. Sean?
Well, I'm a producer of The Unknown Quantity. I've just been a fan and a bit of a nerd, so I enjoy tech. I enjoy the commercial space business. I have an MBA, so my specialty is in the business side of it, and I like to know where the money goes. So, but my ultimate goal is to tell the story of the commercial space business.
All right, Jeffrey?
I'm Jeffrey Liss in the Chicago area. I'm director and former senior vice president of NSS. In real life, I'm a retired attorney and also write some science fiction, published.
And Colin from the North Pole?
Yeah. No, hi, my name's Colin Lennox. NASA Workings Group. I'm working with our Ecology Solutions. My personal business is Eco Islands LLC. I'm in central Pennsylvania, and we do biological mining, so self-organizing wetland bioreactors for biological life support and ISRU, essentially. Yeah, thank you.
And Eric?
Hi, Eric Bethke, CEO of Million on Mars and Bike for Mind, and I do enterprise AI solutions and games applied to space.
Okay, David?
Hi, I'm retired from NASA, a mechanical engineer by degree, worked in electrical and systems engineering, test and verification, design for maintenance. I was on the space station program where I was lead for maintainability, reliability, maintenance planning. Also moved over to the exploration systems engineering advanced development office, involved with the pre-constellation planning for Moon and Mars, various systems and elements for that constellation system engineering, formerly lead for safety and mission assurance for Orion crew and service module. My interest in space goes back before hearing about Gerard O'Neill in high school and setting up a couple of L5 chapters, Jacksonville and Gainesville, with NSS now, on the policy committee. Did a lot of work with Anita Gale on the Space Settlement Design Competition, and currently have a project in New Hampshire that I'm looking at setting up and analog in what I consider a seasonally remote 338 acre property up here that's conservation priority for the town, and we're looking at how to demonstrate space development, settlement type technologies that have an earth conservation value to them for the community.
Excellent. And I was saving Thomas and Michael for the last, because they're sort of the reason why we are meeting. Could I have you guys introduce yourself, and then after both of you introduce yourself, if you could just sort of explain a little bit about how we got to this meeting.
Michael, you start.
Okay, sure. Hey, I'm Michael Lane. I know about a third of y'all on this call. Thanks for being here. I've been with the space community commercialization for the last 25 years. Started out working on space elevators, bounced around a lot over the last 5 years or so, been doing a lot of media related work, and I'm now getting back into lunar elevators. Okay. Within that background, because of the media stuff that we were doing, I've hosted probably 35, 34 online conferences during the pandemic, and then used that to do a bunch of podcasts. So we've got a couple hundred hours worth of content. And in the course of doing that, I've worked with Tom Olson for a long time. We've known each other 25 years. And I'm on the board of his Center for Space Commerce and Finance, and we did a podcast about 2 weeks ago that has had some really interesting ripple effects. And I'll let Tom talk about the center, and then Doug, you can talk about the ripple effects.
Right. My name's Tom Olson. It's basically Michael's and I fault that you're all here today.
Thanks.
I've had a bit of an interesting career myself. I was a biologist by training, and then I went to engineering for a while. Then I got into computers. I ended up a 31-year IT career, of all things. But during that time, I got back into space advocacy in 1996, going on 30 years. So I'm a 3 times lifetime member of the Mars Society. I was on the board of directors of the Space Frontier Foundation for about 6 years. From that, we spun out something called the Center for Space Commerce and Finance, doing the New Space Business Plan competition and space investment summits, and we do micro grants now. But I also, for a long time, helped do the business track at ISDC for many years, and so we're reviving that this year at this year's ISDC in here in Orlando. But the reason we got into this, we had an incredible guest a week and a half ago or so, named Mark Levinson. He literally wrote the book on shipping containers, and the history of how the shipping container was developed and then turned into this enterprise that enabled global trade at a scale never before seen in human history. And it's called The Box. And that was his first book. There's another book. There's a follow-up thing he wrote called After the Box that's also really interesting. And he's written 5 other books beside that. So he's just a fascinating guy. Interestingly, when he first came on the show, he's wondering, well, why am I talking about space stuff? What the heck do I know about that? I know nothing. And we talked him into it. He came on, and we had this glorious conversation that that Doug was a part of. I decided, you know what? I'm inspired. I want to do something about trying to do and see what kind of long-term future. How are we going to ship stuff to space? How are we going to, in a bulk way, and get stuff back again, manufactured products or raw materials or whatever we think we need from, asteroid mining or whatever. And you guys ship stuff out there, lots and lots and lots of stuff. And while we're not there yet, we are poised to do that with the development of Starship and maybe other means to get massive amounts of material up there and start getting lots and lots of people living there. And maybe time is now to start looking at that methodology. And so we'll have something that we can point to and say, we can put this in place when the time comes. And I love this because I call that a space scalable thing. It's I have this term, it's called space scalable. Normally that's for a company that makes things that are really, really worthwhile on Earth, but can be scaled for a space use when the time comes. And we're kind of on the edge of that realm. We're talking about shipping containers. So this is a really cool conversation to have. I'm amazed as many people are on this as I thought there might be. I thought it'd be Michael and I and Doug and maybe one other person. And then look at all you guys. This is amazing. And I am done talking. I'm going to sit back and listen. I have a lot of different hats that I wear. I run the center. I have my day job with Avialto, which is a communications company. Today I'm wearing my podcast host hat, and I just want to listen to you guys. So I'm done. Thank you.
Okay, thanks for sharing. Yeah, so that sort of provides the context. What I'd like to do from here, let's see, it's 5:20. I think we did pretty well with the introductions. I appreciate that. And just sort of set the context, I was, I was inspired, and I spent, I don't know, 6 to 8 hours just sort of like thinking what would be the logistics, what would sort of be an ideal logistics systems between Earth and the Moon and Mars. And I started doing some calculations and really trying to, in detail, think it through. And I've come up with maybe a portion of what the concept might be. I don't know that I've ever heard somebody lay out sort of an end-to-end shipping system between Earth and the Moon and Mars. Has anybody heard of somebody going into detail about this?
Anita Gale has incorporated that into the Space Settlement Design Competition. It's in the program book that she uses. In that competition, she calls it a task, and I forget exactly what the acronym stands for, CASSSC. It's a standardized space shipping cargo kind of concept like that. It's I think, I forget the dimensions of it. It's bigger than a standard shipping container like a Connex. But she had also worked on that concept when she was a cargo engineer with Boeing. And she had a patent with Boeing on the version of it that Boeing was looking at using. So that would be a start.
Yeah. I can't remember if hers was sized for a shuttle bay or not.
Well, it may have been. I don't remember that.
David, you are pretty quiet in your voice. I don't know if you could get closer to the microphone and just try to speak.
I'll tell you what,
louder.
let me try. I just got to where I can get. Yeah, I just got to where I can get to my computer. Let me try to join on my computer now.
David, you sound great now. So if you could just do what you're doing.
Okay. All right.
Yeah.
Okay. Yeah. Did you copy that about the task in the space settlement design competition. And
Yes, I was not aware of that. Did she give as an assumption a specific cargo transportation system, or was it leaving it up to the students to come up with their own?
Well, sort of. So her whole contest was based on the fact you had a series of subcontractors that would be providing different services to your settlement. And then you designed the settlement accordingly, right? So the subcontractors could be delivering things. It depends on the settlement. She would change the type. It rotated through about 9 possible variants, right? Where it was a free space settlement, whether it was a planetary settlement, a lunar settlement, an asteroid settlement, right? So it rotated enough that the teams had to essentially start over every year. She didn't want them accumulating between years, right? But one of the concepts was that you had a series of subcontractors that provided services that fit certain standards, right? And so there were a series of standards that, okay, if it was going to be a subcontractor that provided life support, then it provided air at this level, with this percentage of oxygen, this percentage of carbon dioxide, blah, 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 right? And so that was how her competition was organized. It was set around a series of standards, and the cargo was one of those standards, if I remember right.
Right.
I mean, it's been a while since I judged the competition, but yeah.
Yeah, and actually, the competitions originally didn't have any subcontractors. Once we started to see commercial space activity, that was one of the changes on the 5-year cycle when she and I thought it would be a good time to bring in the idea of commercial space through this subcontractor arrangement.
Could you repeat the name of? Could you repeat the name of the
students never had to define what vehicle stuff was being launched on. It was always just, here's your shipping container, like you said, Bryce. Everything has to fit in that shipping container, then they tend to get reused. They'd be either ship stuff back in them, or they'd be encouraged to use them in construction, take them, build with the shipping containers and so forth. But they had a pretty elaborate system about that. And like I say, it was kind of loosely based on the patent that she had done at Boeing.
Hey guys, let's pay attention when other people have raised their hands to make sure we make a break in the conversation. Matt, did you say what you needed to say?
No, I wanted to ask David to repeat the name of the person who did this, because I didn't.
That was
Anita Gale.
Anita Gale, yeah.
Okay, thank you.
So what I'd like to do in this meeting
I'll put a link to it in the chat.
Yeah, and also, Sean, I think you posted the link to the video. Is that right? Sean, you're on mute. Sean, you're on mute.
There we go. Yeah, that's the video. That's the video from the interview with Dr. Mark Levinson. It's the full interview. It's no shortened clips.
And I put in his LinkedIn connections and a link to the book.
Bruce has his hand raised, but before we are sort of getting into the discussion, which was the last part of this meeting. Let me just sort of tell you what I'd like to do. I've created a presentation about sort of my concept for the end-to-end transportation system. So that's going to take me 15 to 20 minutes to get through. And then I want to open it up for discussion and then see if we wanted to do anything specific about this. If we as a ad hoc group right now wanted to think of an idea how to in a practical matter move this forward. Bruce?
Yeah, hi. At some time during this conversation, I'd like to give a history of the aircraft shipping containers. When I was a child, more and more aircraft came out with standardized shipping containers, but they were tailored to different aircraft. I also have a sketch of how you might have shipping containers inside a SpaceX Starship. So, Doug, at whatever appropriate time, I'll give that background over.
Okay, Bruce, I tell you what, how about just as soon as I get done with my presentation, let's hand it over to you. And then you can go ahead and present your part, and then we'll open up for discussion. Sound good?
Go ahead. Go
Okay.
ahead.
So let me go ahead and share screen. Well, let's see. Okay, do you guys see the screen?
We do now, yes.
Okay, Daniel Tompkins is joining us, just to alert you to that. Okay, and do you guys see my title slide? Do you guys see my title slide?
Yes, we see it.
Okay. So this is sort of my standard presentation, Earth, Moon, Mars cargo transport system. And again, these are just the ideas that I've pulled together. Just to preview, if my advancer doesn't seem to be working. I think my system resources are limited. Okay. So we've done introductions. We've set well, I'll set the context, and then I'm going to describe, as I see it, the types of payloads or types of payload bays, and then the choice of shipping container choices if we are actually going to have standardized shipping containers. I'll explain why I'm not sure whether we'll have standard shipping containers or not. And then I'm going to sort of run through a scenario all the way from, where you order something from Amazon and it's delivered to KSC, and then how that gets to, I'll use the lunar surface, but it could be Mars just as easily. And then Bruce will go ahead and share what his thoughts. That will open up for discussion, and then discuss if we have any ideas of what to do about these ideas. Okay, so introduction. I think it's already clear that this is sort of as a result, sort of a quick result after the unknown quantity presentation. I think that was 2 weeks ago. So the context is, as I see it, the Starship fleet, in my opinion, really looks probable. I think the remaining development steps are going to be, in my opinion, largely accomplished within the next 2 years. And the Raptor engine production rate can support the production of probably at least one Starship per week. And it's going to increase from probably it's about 7 engines now per day to 3 to 4, I think. And then there's a Starship factory to go ahead and build the bodies, at a rate of probably faster than what like 757s are produced. So SpaceX is really serious about, full reusability, large number of spacecraft, reuse them quickly, and just transport a tremendous amount of cargo and passengers ultimately to Mars. But I think if we can get the government to fund the building of a base, I think a very large and growing base can be developed. So in that context, there is a need. Elon speaks about shipping 1 million tons of cargo to Mars before 2050, and so there's got to be some sort of shipping system, as I imagine. So the type of payload modules, this is really the thing that I'm really not sure about, and that is, there have been some renderings where the idea of you have this clamshell sort of thing in which you could have a singular shipping container that comes out from that. In which case, what is inside doesn't have to be in sort of intermodal shipping container size dimensions. It's just a huge bulk payload. And the thing is, I think that this would be fairly easy to transfer from one to the other, whereas if you have to transfer individual shipping containers, that's more of a challenge. And yet we have images like this, sorry for the low resolution, but it's SpaceX rendering showing like delivery of individual pieces of equipment, or you could imagine individual shipping containers. And there's a lot to be said about individual standardized shipping containers to go between the modes of transport. I just don't know which of these two approaches it's really going to turn out to be. And let's discuss that in discussion. Now, the shipping container, I think probably most all of you know this, but the intermodal system is just remarkable, and it has unbelievable facilitation of international trade. But the idea is you produce something in the factory, you put it in a container, you close, lock, and seal the container. Forklift goes and puts it in a truck. Truck takes it to the port. It's loaded by cranes onto massive ships that hold, I don't know, thousands of shipping containers.
11,000. I asked him that after we were off
Wow.
screen. 11,000 per ship.
Yes. And then they just ship it across the oceans into another port where they unload it, and they put it on either trucks or trains, like trains that delivers it to the interior of the country, in which they are unloaded and distributed to regional distribution centers. And then a truck comes along. There's standardized pallets being taken out and sorted and then reassembled into the shipping containers that transport it to your friendly Walmart, and people are unloading pallets and put stock in the shelves with your stuff. And the cool thing is that once that shipping container goes in the factory, goes into the truck, it's just large amounts. Man, in the presentation, before we had this sort of system, you had people handling with their hands individual pieces of product, and that took so much time and so much money, and this is just a far better system. Now, this, as I see it, and there could be more than this, but as I see it, there's unitary, sort of singular, like a really big habitat, for example, payloads. But there could also be liquid, like, for example, could you imagine shipping ammonia to the moon and just a single container, and it's drained out, and now you've got enough nitrogen, if you recycle it, to support the lunar base for a very long time. There could be bulk material where it's all one, but maybe it's some sort of powder, grain, or whatever, like I don't know, something like copper, just bulk. And then you could have individual shipping containers, and it could be that within a single delivery, you may have some of these shipping containers going to different in time. It's landing. The Starship is landing at the regional spaceport in the South Lunar Pole, let's say, and then these individual containers are the tethers drop it down to the surface. There's individual self-driving big rigs, sort of electric big rigs, and they attach the container on, and then they're off on a compacted dirt road over to some other base, some other settlement. Bryce, you just raised your hand right now. Did you want to insert something?
So you brought up a very interesting concept that's different from Earth containers versus space ones, right? So yes, in a shipping container, you could theoretically have a refrigerated container that fits inside the shipping container. In our case, if we're shipping something to space, are we going to assume that we're going to create, as part of the shipping container standard, a standard for the environment that the shipping container has to maintain inside?
Yeah, I'm going to get to that. And what I'd like to encourage you guys to do, feel free to interrupt if you wish, but also write down your questions or points, because something might trigger your thinking right now. And then when you get it into discussion, go ahead and bring up those points. And let's not forget them in the excitement of the presentation. So Bryce, I'm going to just hold on, because I am going to address that here shortly. We're getting into it. So pressurized versus unpressurized. So it could be that some things are fine to expose to vacuum, but other things, like this is something I found on the internet. It has the frame of, I believe, an intermodal shipping container can be handled in the same way, and yet clearly it's a pressure vessel inside. And there's probably some sort of gas. I don't think it says it there, but it's probably some sort of compressed liquefied gas. Okay. So, I'm no expert. I'm just, I'm a I'm a space advocate that's totally winging it, totally out of my element probably. But here's my thought. In my opinion, let's leave the imperial system behind on Earth for good. Let's not take it to space. Do I hear a hooray?
Right.
Okay.
Amen.
And yet the shipping container, it's like the height is, I don't know, 8 feet and 6 inches. That's like the definition. So it's defined probably by the United States and imperial system. And yet like the width is 2.55 meters. And what I'm suggesting is maybe to just go 2.5 meters by 2.5 meters by 2.5 meters, but then have in my mind, looking at the Starship fairing diameter and the height and how it tapers in, is to have, I'm going to use a CubeSat, nomenclature of 1U, 2U, and 3U shipping containers. And I don't know, maybe there's some advantages to just having, it just be a perfect cube and then in the different sizes. Okay. I don't know, but this is what I've come up with. So 2.5 meters on a side is sort of what I'm imagining. Okay. So I took a look at the fairing for the Starship. And what I did is I said, okay, how many of these different sizes of containers can you fit within the fairing? And I have that it is 16. And I just printed on cardstock. I printed these things. And let me see if you can look at my picture. Right here, I've got, actually on the floor as well, I've got like these things that I've created. And I've sort of come up with an idea that there will be four levels of the 7.5 meter, the 3U shipping container in the middle. And then on the sides are four 2U shipping containers. And then above that on the 5th level is two 2U shipping containers. On the 6th level is one 2U shipping container, and at the very top is a single 1U shipping container. And as I look at it, it looks like that all can go ahead and fit within the fairing of a Starship.
I can't figure this out from the image. Can you give me those numbers, layers 1 through 4? What are those numbers again?
Okay, so each layer, the bottom layer is going to be a central 3U shipping.
I understand. I just want the number.
The 1 3U in the middle, two 2Us on the sides.
1, 2, 4. So first one is 1, the next one is 2, the next one is 4. The next 4 layers, how many on each of those 4 layers?
I'm confused. There's 3 shipping containers for each layer on the bottom 4. The central one is a 3U. The lateral ones are 2Us.
So a total of 7 per layer.
Total of 7. Thank you. That's what I was looking for.
Well, but a 2U is a single shipping container. So there's really only 3 shipping containers on the bottom.
Okay, I was just trying to get the U's. I got it.
Okay. 2U, 3U, 2U. Same for the four rows. And then 2 2Us, 1 2U, and the 1 1U. Okay.
I'm good. Thank you.
And I just didn't have time, but I wanted to put a drawing in the back and take pictures shows that it does in fact fit it within the fairing.
Would you anticipate, so one, you have the space in the corners. Would you anticipate a support frame? You're going to have something.
Yeah, because the thing is, I think from the image that SpaceX shows where you have this door open up and you have the central doorway that's sort of small. You can launch a small door, but launching a large door might be, or max Q might be a problem. So to me, it's a question of, I think that there needs to be rails, and I think there needs to be a way to be able to go and put the 1U all the way up, and it clicks in at the top, and then you put the 2U, and then you put 1 2U, put it over the side, 1 2U, put it over the side, and then you have the 2Us that you put up on the sides, and then the 3U, 2U on the sides, 3U, etc.
So in addition to a support frame, your cargo containers and so cargo containers on ships, for example, around the corners, all corners around the cube structure, right? And then in additional spots are actually support points, round little places where the above one couples to it, and then you put a thing through it to seal them like that, right?
Yes.
And so that would obviously that's probably something I'm sure you're thinking about here. But if you have a support frame, they can also add to the support frame like that too, right? So if you have like a support frame with a bunch of holes in it, then that loop would go over the hole and it could lock in there. Now the only problem is it's really easy on a ship to crawl over people to set these all up when you drop them in by a crane and pop them in. Is it going to be easy to do that in space? Is a question I asked at a group.
So there's no crew in spacesuits going and inserting pins or anything like that. This has got to be in. You keep fitting them in a certain order, and then in the motors they put them up and lock them into place. You know, as I see it.
So the shipping container would have to maybe have a motor on it in those support places to drill the screw to put the bolt in to lock it.
Or the frame has locks and you just put it into place and then the frame locks it into place.
Yeah, you would have to have a servo to do that probably, but
yes. But let's hold that further for discussion. Yeah. Okay. So there's, and also I don't know to what extent there are smart containers, but I'm thinking a standard could be set where, and I don't know. I mean, there's all sorts of labeling of containers and they mean stuff. I have no idea what they mean, but they mean stuff. And so I'm sort of imagining that perhaps there could be sort of LED panels and the shipping container could have a code on all sides of the container. And by looking at the code, you can be able to tell exactly what it is. You know, like, I don't know, who owns it, et cetera. You could have like radio transponders in there that, you know, and basically these things need to direct themselves to their final destination, and et cetera, if that all makes sense. Okay. Now, he couldn't join us, but I am unfortunately blanking out his name. Andrew Tubiolo from Tucson. He works with Kit Peak, I think. Anyhow, he's at the university there. So Andrew, he couldn't join, but he says, hey, I'd like to give some input. So this is his input. Every container should measure and record dynamic forces experienced for the entire journey. 9 degree of freedom, gyro, and acceleration, temperature, pressure, humidity, etc. I think that's part of the smart container system. I would be inclined to think that he's onto something there. Okay, so let me take you the scenario as I imagine it of how does something go from Earth to, let's say, the moon, okay? So I think what this entails is probably having a receiving facility at Kennedy Space Center that can, you know, you like literally order something, you know, somebody in the settlement on the moon says, hey, let me go ahead and order something on Amazon. I pay for the shipping, and it is, you know, Amazon truck pulls up at some warehouse on Merritt Island, and there's people there that receive it and they put it in the location and put a label, whatever, they scan it, and it's into the database. And there's some sort of pretty sophisticated system. I think logistics companies do a really great job in handling all the details of, you know, faithfully. And yet there are people or robots that are assembling these shipping containers with exactly what needs to go to that particular settlement on the moon. Okay. And there's like just in time, I mean, there is a very sophisticated system that knows what needs to go where. And if there's empty space, well, let's go ahead and put in some copper slugs, you know, and you're just sort of optimizing all sorts of things. And then in my mind, you got these 16 shipping containers that are being loaded up with different things. And then they are trucked out to the launch site. If it's not a unitary container, but these are individual shipping containers, then they're transferred on probably electrical vehicles to the tower, and there's got to be a system to go ahead and take these containers up and start loading them up into the payload bay. I myself prefer a unified container. I don't know if that'd be the top half of a starship, the upper stage starship, because I think we need to turn these vehicles around quickly. And I think spending 45 minutes loading in containers in the payload might not be the best use of time. Okay, so LEO logistics facilities. Now, do we need something in Earth orbit to take these shipping containers, and this one's going to Mars, this is going to the moon, or do we have a cislunar transport vehicle that doesn't have landing legs? It may have a heat shield, and then transferring the cargo, the shipping containers coming from the Starship, and are the individual shipping containers being pulled up and re-put in, or can you have a mating between vehicles and then do the transfer of the shipping containers between it in just an automated system that doesn't require an external thing with arms and whatnot? So I'm just throwing these out as questions that I hope that we can discuss. EML1 logistics facility, especially like if Blue Origin is harvesting ice, producing propellant, or somebody's producing oxygen for Starship, and you have a lunar ferry that doesn't have a heat shield and it's refueled on the moon, goes up to EML1, which is about delta V, about halfway between LEO and the lunar surface, which I think is, it's the rocket equation, I think, wants you to be about halfway in between. Do we need to have a facility there to facilitate the transfer of cargo from one vehicle to another? Eric is rejoining us, I guess. Yeah. If somebody could, I'm getting feedback. Eric, you just joined us. So maybe the feedback is from you.
Yep. Trying to turn off.
Let me see if I can mute you. I'm going to mute you, Eric, if you need to unmute yourself. Okay, so I mean, this sort of gets into the gateway debate. I personally would prefer not to have a middleman in the middle of a relay race. I think you have an incoming vehicle, a downgoing vehicle, and I think it'd be nice to be able to just transfer cargo and crew modules between these vehicles and not have to hand off to a middleman just to hand off to the craft. Okay, but we can debate that. Okay, and then the lunar receiving facility, I see it as being located right next to the regional spaceport. Like, I have a specific location chosen on in the South Pole region. And in that spaceport, it's far from everything. It has these dirt roads to everywhere, and the shipping containers are offloaded, and then there's vehicles just waiting for them to be plopped right on them, and immediately these vehicles are going to their destination. So I don't know that you need a receiving facility per se. You just need good logistics systems to know what shipping container needs to go where, and you don't want to divide the cargo within the shipping containers between different facilities. Otherwise, you do need a receiving facility. But you do need a receiving facility at each base/settlement, and then either people or robots. These shipping containers would be brought in to a pressurized environment, and then they're opened up, and you got sort of automated forklift systems that go and take the stuff out and start sending them by little robots within the Starship to the store, to the cafeteria, to some individual person's habitat or room, etc. And then I sort of mentioned about surface transport. I would like to see a standardized surface transport system that could have modules that would be shipping containers or cargo containers or liquid containers or crew vehicles that are shielded from radiation. And so I'm sort of totally into standardization. So let me do this. My wife just called me, so let me go ahead and call her back. But let me just hand it over to all of you guys to just sort of begin bringing in. Oh, I'm sorry. Bruce, can you go ahead and sort of take it from here?
Yes. Yes, I can. Um, okay. I'm trying to, can people see a white screen? Um,
Yes, thank you.
I'm trying to make it bigger on my screen than I can. Okay, so when I was 9 years old,
Bruce,
my dad was a, yes.
Bruce, I'm gonna make you co-host if you want to share. Share screen.
No, no, I just want my video seen.
Okay.
Okay, so when I was 9 years old, my dad was a commercial pilot flying freight contracts for the Air Force Logistics, and they had a British turboprop four-engine propeller, and it was extremely efficient for carrying cargo. They had a hatch, the entire nose of the aircraft swung out. The pilots were up overhead like a Boeing 747, and the entire tail swung out. They would fly into an airbase, and the Air Force ground crew had military discipline, and they'd drive a truck up to the front and the rear. They'd push all the cargo on rollers. The airplane had rollers built into the floor. They just push pallets out one at a time onto the truck. At the same time, a different crew would push pallets in from the rear, and they got record times for loading and unloading. They could do it faster than they could fuel the airplane. And around that time, in the 1960s, up until the 1960s, airplanes were loaded by hand. They would use a pallet jack and pallets and boxes, and a lot of workers would just carry boxes inside the airplanes and strap them down, or they'd have pallet jacks pushing inside the airplanes. And Boeing and McDonnell Douglas and other air manufacturers tried to standardize their fuselage diameter, and then they came up with a pallet system. So up here is a typical pallet, and Boeing tried to make all their pallets the same size, but then they came up with wide bodies, and so they'd have to make half pallets or big pallets. And then in the belly of the plane, they would have half pallets. And they tried to offload and load very fast this way. By the way, as a side note, the 20, 40, and 60-foot ocean-going shipping containers were invented by a Scottish engineer who had a shipping business in Philadelphia, and that's why they are metric sizes. If we're going to do another side note, for efficient packing, just 7 cylinders is the most efficient way to go. If you want pressurized fuel, you can pack 7 big cylinders, almost 3 meters in diameter, into a Starship. So there's a whole bunch of questions as to whether we want, pressurized or not. After Doug and I talked by phone, I tried to describe this system where you have roughly rectangular shipping containers, but so this is a cross section of a Starship. But notice I've rounded the edges of the shipping containers so that we can get them right up against the edge. And you can also have them kind of faceted. And in the middle, I just use the same shipping containers with rounded edges. I just waste a tiny bit of space, but that means that they are all standardized. And you could, of course, put a cylinder inside one of these rectangular frames. So this is my proposal off the top of my head. And a side view, you might have them in layers. You might take 1/3 of the height of Starship and have them that high. And then up in the nose, you'd have fewer, maybe 2 or 1 or whatever. Here are some of the issues. They need to take all the G-forces in a known direction. So you'd always put the shipping containers in right side up. So the launch forces are always anticipated as what they're going to be. Actually, that may not be possible for the landing forces. And so you got the issues are the direction of the G-forces, whether they're pressurized or not, temperature, radiation, vibration's a big one. You can also have half-size and quarter-size containers and combine them into a bigger container. As far as loading and unloading, you want to have a minimal size hatch for the structural integrity. And I propose that you just somehow shift the containers left and right and up and down until they come to the hatch, and then you take them out. Ideally, you would have a Starship land, you'd be caught. So a Starship would come back from orbit, land, be caught by the chopsticks, set aside. You'd unload the shipping containers and reload more containers, and then stack it back up. And you could probably do this pretty fast, about as fast as they can, do diagnostics on the engines and refuel it. So that's my thoughts.
So is that? Can I ask a question? Is that center area? So with the center area is a support space and the open space, and then the outside is the shipping containers?
No. I would have 5
Okay, I got you.
containers
I would miss
per
that drawing.
layer. And you'd have some kind of support frame in there that can lock them in place. And then you also need to unlock them and raise them up and down to the hatch.
It's possible your half container would be a prism in shape.
Could be. Yeah. For this cross section, there are little triangular sections.
Yeah, that one. That's what I'm talking about.
I would just waste that space or put plumbing in it. From my experience as a child in the aviation industry, you don't try to optimize everything. You in this case, we're optimizing speed of unloading, and some vehicles can hold a maximum weight, and they're restricted by how much mass they can carry. Some vehicles are restricted by how much volume they can carry.
That actually you actually created an interesting point there, because if it is clear right there on those areas around it, then sometimes you need access points while you're loading it anyhow.
Yep. You could have people or robots or locking mechanisms go, in those little triangular spaces. So okay.
A good thing to consider here is how would this particular design work for other launch vehicles? I mean, you want to have a design that's common for any launch vehicles or other methods of shipping them, like once they're on the surface on a train or something.
I think that's either Dan or David talking. So David. They ran into that problem with aviation. They had the 707 class fuselage, but then they had the jumbo jets that were, you could fit 2 pallets down the middle. And they tried to standardize the pallets, and they really couldn't. So they ended up with, one set of pallets for jumbo jets, another set of pallets for normal size things. These that I just showed, especially the ones with rounded edges, they're optimized for a 9-meter diameter fairing, and but you could fit them in a like a 4.5-meter diameter fairing if you had to. Any other comments or discussions while I have the pictures on screen?
Yeah, also for Earth-based transportation systems, rail or ship.
Well, these would be almost 3 meters in most dimensions, so that's about 10 feet, so they could go on a truck.
Okay. I mean, those, if you're thinking of standardization, that's the kind of you gotta consider is, how widely usable is the standard.
By the way, that's Dave Chevron talking.
Yeah, Dave, what I'd say on that point is I think that we need to bite the bullet and say there's going to be different standards on Earth and off Earth. But just like has happened on Earth, when we got to standard shipping containers, the train transport vehicles, they started adjusting to the standard. And the ships adjusted to the standard. And that's my feeling, is that in the future, I think we may be forced to do, Blue Origin has their standard and SpaceX has their standard, but I think that we need to try to get it to where there is a standard off Earth, and then the ships need to accommodate that.
Yeah, Doug, let me adjust that slightly. let's say we have one standard for SpaceX starships, but that standard can be transported on the ground. So there's some way of taking these containers on a truck or a railroad or a container ship. So maybe we take these containers and we package them inside a shipping container and then ship them on a ship. Over.
Yep. What's not commonly known about my background is my very first years straight out of high school were in the Marine Corps, and I was assigned to be a logistics and embarkation specialist, whatever that means. But in real world, it means getting stuff from where it is to where it needs to be, specifically on ships. And I think Bruce is completely right. Whatever we design has to fit within the current transport system, because that we're not going to change. Standards exist in the world, and it's not going to shift.
That's Michael Lane talking.
Yeah, correct. Sorry. Yeah.
Michael Lane had pet aircraft carriers. He showed me. Over.
Michael, what I'm saying is I don't see off-Earth shipping containers being used on Earth. I don't think we should try to have just one standard for Earth and off-Earth. But what I'm saying, so there will be receiving facilities at Boca Chica and KSC and elsewhere, and there will be some reassembly from one shipping container to the interplanetary.
You mean transshipment is what you're talking about,
right?
Yeah. And with robotics,
this is getting this is Dave Chevron. This is getting into what we would consider a very good subject for a formal trade study, where you list all the different options like this, and you go through and figure out the attributes of what you want to rate each option against in terms of whether it be labor on repackaging stuff or whatever. You need to really go through and look at what are the pros and cons and weighting of the different attributes or metrics on something before you just decide arbitrarily one thing's better than another.
Well, I mean, I agree with that. I think we want to eliminate, unpacking and repacking things. We want to make everything, at least initially, we want to make the things that we're using in space be easily compatible with what we're using on Earth, without having to empty and repack things.
That was Matt Johnson speaking.
Yeah.
So I do think you want to be able to ship these containers on trucks and rail and ships. So I could see an aerospace firm in Seattle build something. They put it inside the space shipping container, and then a frame around that is compatible with trucks and rail.
Mm-hmm.
And so you take rail to Kennedy, you take a truck from the rail yard to near the launch pad, and then you take off the frame, and now you have the space optimized lighter weight structure. Over.
If the interplanetary shipping container was a little bit smaller, and the beauty is that in my concept, 2.5 meters is smaller than 2.55 meters, and 2.5 meters is smaller than like 2.8, I think, meters tall, and so my proposed standard would fit in. You could put a frame around that to match the Earth intermodal system. Aiden, you have your hand raised?
Yep, just a general question. How much mass can Starship realistically return to Earth? Because some spacecraft, they have a mass that can go up and a mass you can return with, like the Dragon capsule, for example. Have we considered that? Thank you.
I think
they've advertised 100 metric tons going up consistently, but there's always trade-offs, and it depends on how much fuel. They may have shorter or longer versions, more powerful engines. So I don't think we have a final number yet.
It's going to be a very small fraction of 100 megatonnes.
The shipping container is going to be a small fraction of 100 tons.
No, I'm just saying mass down from a starship on a starship isn't going to be 100 megaton. You aren't going to bring 100 metric tons down. It's going to have to be a much smaller fraction, I would think, unless they get really good at the heat shield stuff.
I'm sorry, I'm confused, Bryce. We're talking about shipping stuff from the Earth to the Moon and Mars, and you're talking about shipping stuff back to the Earth?
That was the question that somebody was talking about how much that was what the student asked. The mechanical engineering was asked, the student, I can't remember his name, was asking how much can it successfully bring back?
Okay.
Right? Because if we're talking about shipping containers, then it's going to be, I mean, in our tense, it would be like this. Maybe you can send 10 shipping containers up, but you might only be able to safely bring back 5 or 6 because of the hardship of bringing it back down the gravity well.
Okay. If I could answer that, many airplanes have a much higher mass going up for takeoff, and then a lower mass that they can safely land with. And that is especially true to avoid damaging the landing gears. And it's true for a lot of spacecraft too. But very early on, like more than 5 years ago, Elon or somebody at SpaceX was saying they need to be able to have a case where they cannot deploy a payload. So they take 100 metric tons up, they try to deploy it, and they fail. They need to be able to bring that back without and save the vehicle. So they were early on planning that the down mass would also be 100 tons. However, I have not heard that recently, and incidentally, a major problem is the weight and balance, how much weight you have at the front or the rear. So you could, depending on the size of these control flaps, you might not be able to bring maximum weight down in the nose, even if you could bring it down if it was more evenly distributed over.
Well, another interesting consideration, since we're going down this route, is maybe you could transship. You have some cargoes that you bring up into orbit, and then you shift some cargoes for transport from Earth orbit to the moon. So theoretically, you might actually pack things tighter going from Earth orbit to the moon in a starship, or heavier maybe, right, than you would going from directly from Earth to the moon, right? Because you could transship them in orbit.
The real advantage of transshipping is different containers can go to different destinations. You know, so a ship comes from Hong Kong to Los Angeles, and then you put them on a train, and one train goes to Chicago and another train goes to Kansas City. So the comparable thing in space would be some of the shipping containers stay at the space station, some go on to Luna, South Pole, some go on to cislunar space, etc. Over.
You guys, as I thought about this, if you, for example, if you were to make the shipping container out of copper, and then you just deliver the container to the moon, and then you just melt down that shipping container and use the copper, because it's really hard to extract copper from the moon. So it could be that shipping containers will be a resource itself.
Yeah, exactly.
You also might make them out of graphite and then burn the graphite in your greenhouse over.
Yeah, you could do that too. I mean, there's a lot of options. Honestly, you could just use the shipping container as a structure, just like you do at a lot of off-grid places in the U.S. or in other places. For example, the Flamingo Hotel in Florida, where Everglades out in the remote area. What did they build it out of? Shipping containers, because they just had them.
Aiden, you have your Bruce. There's a hand raised. Let's let Aiden speak.
Why not use graphene? Isn't it incredibly light? Thank you.
Yes, you could use most any light material, aluminum, titanium, graphite, graphene, etc.
So we'd be talking about a structural standard and a mass standard for the container. We wouldn't really tell it what material it had to be.
Well, the standardized things are the outer dimensions where you lock them in, the maximum dimensions, and how much G-force they can take and the direction of the G-force and whether they're pressurized or not, things like that. But whether it's aluminum or titanium or graphite or graphene, as long as it locks into place with the containers, the material is flexible. Somebody, I think it was Dan Tompkins, said, "How about connecting these together to make a habitat?" And the habitats really need curved walls to stand pressure, but you could have a cylinder inside the container, or you could go back to my idea of having a bunch of cylinders, and you could connect those together, disconnect them, and reattach them in other ways. Or you could ship up an additional module and lock it in. And Dave has his hand up.
Thank you.
Okay. So I think probably best to assume that the shipping containers, at least initially, there should be some reuse of them once they get wherever they're going. Leaving it totally open to making it out of whatever the provider of the shipping container wants would probably have a negative impact on the recycling and repurposing types of technologies needed. So that may be advantageous to also standardize on certain materials. And it's not maybe, there could be maybe a metallic version and a graphene version or something like that. But think in terms of how this would be repurposed or reused or recycled from the beginning.
Aiden has his hand up again.
Have we considered plastics? I understand a lot of them would not qualify, but are there any plastics that have a chance of qualifying? Thank you.
Yeah, plastics would be very good on the lunar surface. They'd be worth their weight in water. As long as they can interconnect with the mechanism that holds them, I think they can be any material. Over.
Well, they're going to have to be very strong to support, liftoff with the cargo weight inside them. But I think they could be a lot of different materials. And I think the idea of shipping on a container that stay on the moon or Mars and be used as a resource there is also a really valuable idea.
Yeah, there is a question of whether the container can hold the weight of the container above it. On ships, they can. You just stack them up, lock them together, and the lower containers hold the upper containers. But if you're pulling 3Gs, 5Gs on launch, and 7Gs during an emergency reentry, maybe you want a framework that holds each one separately. That's a design issue that has to be worked out. Over.
Or the container contains a frame itself that is the structural support member because shipping containers on Earth, of course, don't do that, right? The material is the frame, right? But we could make our standard say that the material that it has to have a frame that can do the following, and then after that, the walls can be anything.
Yep, yeah, and in fact, you can have on Earth a cylinder inside a fairly light frame, where the cylinder it provides much of the structure, structural stability, and the corners of the frame are just to lock it in. Over.
And remember, we have strong temperature variances and vibrations too, in addition to G's, right? So not just the ability to handle G's, but the variation in G's and the variation in temperatures could make some materials too brittle or fragile at those vibration levels.
I think temperature variation is something you can control. If you pressurize the container, you can have ship things that are more delicate.
I'm talking about outside the container. I don't know what the Starship is committing to when you put it inside.
Well, right, but we can figure that out, right? We can say at least some of the cargo starships will be pressurized and temperature controlled. You'll still have vibration and G forces.
Yeah,
Eric.
that would take care of a lot if it was temperature controlled, that's for sure.
Yeah, you wouldn't want to do it for all of them, but some of them.
I'd like to swing back. Oh, go ahead, Eric, first, and then I'll go.
Oh, could I share a screen?
I can't give you that. Doug's gonna have to enable that for you.
Yeah.
Right.
I might have co-host, but I can't find a way to do it.
Yeah, co-host can't do that.
Yeah. I'm also on a smartphone, which is
Okay. Then I'll do something else. I will put a link into the comments. Maybe somebody else can share.
Doug, are you able to open that link and share screen? Over. Is anyone able to open that link and
Yeah,
share screen?
let me try to share that. I want to go here.
And other people can talk if they wish.
So I was listening to this talk so far, and I just drew that 2.5 inside of a circle. If you'd scroll down, please. Keep on going to a couple more diagrams. So I was scrolling along. Then I hit on 2.2 meter cubes, and I went to go look it up. Starship has an inner diameter of 8 meters. So I hit on your concept of 3U, 2U, 1U. And so I'm just illustrating what I've heard as I went on, as this phone call has gone forward. And if you scroll down some more, 6 of these 2x2x2s would fit in a standard 40-foot shipping container with not very much wastage.
Yeah, so that would give you the intermodal.
Yeah, and then if you scroll down one more time, there's another diagram that's just some sketch to the verticalness. You could have 9 of these layers.
So it's a 2x2x2 cube.
Yeah, and frankly, as long as we're going to skip imperial and go to metric, I'd like to avoid the decimal if I could somehow throw agency into this.
So it's a pretty good drawing. You did all this during the talk, during that call.
Yeah, I did.
You're a lot faster than I would be. This is interesting stuff too.
So 2 meters by 2 meters is fine with me, but I think we need the option of 2 by 4 meters or 4 by 4 meters for at least a few of them. Over.
You could, but then you definitely could, and then that would have to be non-standard in terms of like the international ones, because that's outside the intermodal size.
Well, yes, but sometimes you have an outsized cargo, so you want to be able to accommodate a large cargo somehow. Over.
True. Aiden, you have your hand raised.
Anyways, I was just offering strong conversation.
Yeah, thank you.
I noticed that several of the pictures had empty space. Would it be a good idea to say either A, fill that space with just pure material like steel, graphene, whatever, or could you allow, let's say, university researchers or nonprofits to send up small nanosats using that extra space? What's everyone's thoughts on that? Thank you.
I think you need some of that space, one for support members, and two, just to load the materials, just to load the containers. You need access areas. That'd just be my thought.
You'd also be surprised how many wires and conduits and pieces of equipment you want inside. From observing the aviation industry, I think it's not worth trying to use every last little square centimeter of space.
Agreed.
Also, it matters a lot whether we are mass limited or volume limited.
That would depend on the payload, wouldn't it?
Yes, it does.
Yes, and so part of the logistics system is to sort of right size the payload for these factors. So it's like, we're sending a lot of clothing that doesn't weigh very much. Let's add in some bars of copper into this payload,
Yep, and if you have a bunch of containers from different companies carrying different cargoes, you can do that to some extent. You can add up how much each container weighs. You might even put the heavier containers at the bottom or wherever they're needed for better weight and balance over.
And each piece of product in there might have in the database how urgent it is that it needs to get there. In other words, certain things are not urgent, but they're low mass or low density versus high density, and so you can draw those things to go ahead and fill up the mass for the payload. In a sophisticated system. Hey guys, we're down to the last like 8 minutes. What I'd like to do at this point, I feel like we could discuss it some more, but what I would like to do is to discuss whether as an ad hoc group, I mean, we have no particular plans to meet beyond this meeting unless we want to. What do you guys have an idea of where could this go from here? I mean,
say we come up with a standard.
Do you guys want to meet again and try to work on a standard to propose to somebody?
I think what David said a few minutes ago about trade study, it would be a really useful next step. Half of us are going to be in Orlando in a couple weeks for NSS. That would be a convenient way to do this. I know that there's other folks in the industry in Gravitics and Cislunar Industries have both had separate individual conversations about standardized packaging. I think there's a whole industry that's waiting on this answer. I think there are a lot of people that would participate. I can't believe how much money there is. I think there's a lot of people that would want to participate. I think we can set a tone and the beginnings of this. And I think eventually it can be an ISO standard that ultimately is where it needs to end up at. But I think this is a core piece of the cislunar ionosphere, and somebody's got to do it. Might as well be us. So that's where I'm at on this. And I can invite a lot of people to this thing, and if it starts looking like it's got some legs, I'd bring back Levinson, Dr. Levinson, to just shine his experience flashlight on this. But I know, because I've interviewed them, that there's folks at the US Transcom, that's the military logistics group. There's folks throughout the DoD that needs this stuff. This is an overdue problem that somebody needs to tackle. So I think our first step is what David said is, let's have a meeting, let's do some trade studies, and I'm not trying to force anything on the Space Development Network, but somebody needs to do this. So that's where I'm at.
Before we get to you, Jeffrey, let me suggest I'm going to reach out to all of you who attended and those who did not attend, and just ask who wants to be on a sort of a group email list. That doesn't need, you can attend but not be on the email list. That's fine too. But to sort of keep this going, and Jeffrey, before we get to you. It sounds like we want to go ahead and have a follow-up meeting, and I want it to be efficient and making good progress. And sometimes that's a challenge because it's easy for this many space advocates to talk a very long time and not necessarily get specific things accomplished. And so I'm not quite sure why I say that, but how far in the future would you guys like to have the next logistics working group meeting on this topic? You do want a meeting, don't you?
Maybe that's the first question. How many people want to meet again?
Yeah. Show of hands. How many of you would like to meet again?
Yeah. basically.
on this
Okay, so
topic.
maybe about half of us. Okay, that's enough. That's enough. Aiden, was that raising your hand because you want to speak, or you were showing that you're voting?
I'll be up for meeting again on it, although it may be at least a couple of weeks before I'll have a chance.
So how about 2 weeks from now?
Sure.
Okay,
Approximately
and
that.
let's
Good
feel
work.
free to communicate by email in this group list that I'm going to go ahead and send out. And I'm thinking we might need to have some sort of Google Docs that we can all sort of edit freely. But I think we need to define what we want to do.
So that's smart.
Aiden?
Would it be best to set up a Discord or a Slack or something for communication besides email? And if so, what are your thoughts on that?
Yeah, I'd really like to see this on Discord.
Yeah, let's not set up a new Discord for every topic. Is there an existing Discord group?
I have an NSS Launch Watch server, which is available to put another category and some channels in. I can set that up.
Is anybody against that? I'm not really a Discord user. That's me, but I don't know the rest of you guys.
I'm more likely to find stuff on Discord than having a lot of email.
Okay, we do get flooded with a lot of email. Okay, I think that's right. Jeffrey, did you want to say something?
Yeah, I had a question. There's a total non-technical person. A question that my 13-year-old grandson might ask. Is it totally out of the question to build additional or larger payload doors for accessing cargo? Can Starship be modified?
At this point, they don't have a final design for Starship, or they may come up with multiple designs. But the rule of thumb is you want to minimize the size while still being flexible for a variety of payloads. Over.
If you have a door opening out, what would the size? How would that affect the size?
If it's pressurized, it's better to open in, but you can't open out. Let me say there's one exception. There's a proposal for clamshell doors where half of the entire cargo bay just hinges out.
That's what I was thinking of.
Yeah. So they might have starships that can carry where they can carry a giant satellite as the entire payload, and they just swing half of the fairing out. And in that case, we could use that same one for these pallets.
I suppose the question from SpaceX's viewpoint would be, could they do two different models without seriously inconveniencing themselves for all the other uses they're planning for Starship?
Let's assume they can do multiple models, but they want somewhat standardized, so they want a bunch of one model and a bunch of another.
I understand that. But whatever you come up with, you may want to come up with two different varieties. One with a simple thing that you're contemplating right now, or also maybe what would you do if there was a clamshell or you had a second one in? That doesn't affect your standardization on the inside, but
Starship that's designed for establishing a lunar settlement would be able to take a vehicle, a vehicle the size of a Tesla Cybertruck. So there'll certainly be ones with doors that big. Over.
Well, I hope they're better than the Cybertruck that's holding up. But
so you guys, we are now at an hour and a half. That's sort of our typical closing time. We don't absolutely have to end it right now, but I don't want to keep you here longer than some of you might want to remain. Is there anything else that somebody feels really needs to be said?
I would like to re-ask, does anybody want to formalize this and host a meeting at ISTC, or is that premature? And then the other question is, at what point do we start bringing other people to this meeting? or do we just point them to the ISTC meeting? And I'm just picking ISTC because it's easy and half of us are already going to be there.
Aiden, did you want to answer that, or did you have something new?
Oh no, I was gonna ask who's gonna be at ISDC generally. I'm just curious.
Oh, at least half of us. Me too.
Yeah.
Yeah.
Michael, I would like to have this presented sort of like why not? It's an active topic, and it's just we don't have a standard, so I'm not quite sure what we would present except maybe the questions involved.
I don't actually think we're at a point where we can present something. I think we're at the point where we need to get a lot of inputs and a lot of participation. Honestly, no offense to anybody, myself included, but with a dozen people on this call, we are not qualified to set this standard. So there's other people that have very vested interests that I think there probably is value in developing a consortia because this might be the first box, but it's the future of space is containerization. So I think, and I think there's some value, not to again pressure the space development network, but y'all are a team, and you can take this on as a thing. And if you don't, somebody else is going to take it on as a thing, which is fine. I know, Doug. We talked, and you're pushing, settlement, which is great. But I think this is a cornerstone to settlement. So that's why I'm suggesting we broaden this, get more people that have, a dedicated. There's people that have something at stake with this answer. So I think somebody should take the lead on it.
So Michael, I think the Space Development Network can take this on, but more people would be useful.
Yeah.
So rather than forming a new group, we can form a group within the Space Development Network. Over.
Yeah, I don't want to force that on you and Doug, though. That's not what I'm trying to do. But all right, so we're going to meet again in 2 weeks, and in 2 weeks, let's talk about some more after we've processed this a little bit.
Before we get to Jeffrey and Eric, let me ask you this. Is there anybody in this meeting right now that would like to take the lead on leading the meetings? Please. Okay.
Tompkins, I'm gonna kick your ass.
Doug, look in the mirror.
Well,
okay,
right.
I see a motion on the floor.
I'm one of those. Okay, I'm just going to say it. I'm one of those people that has a vested interest in the answer, right? Because if I'm right about lunar elevators and EML1, this has a direct impact. And y'all don't know this, but I talked to a space architect earlier in the week about a different topic, but getting some standards would help me do what I'm doing. So, I mean, I'll run the meetings if you like. I don't want to be in charge, and I don't have a development network to bring other people into it. So I'll run the meetings if you like. I'm not going to say I'm in charge of it. Somebody else is going to have to be. Ultimately, this has to be their pet project.
I'd like to respond to Michael's mention of lunar elevator. So we're going to take the Starship to take all these containers up to low Earth orbit. I will use one of my rotating tethers that has a maximum capacity. So the size of the tether, the strength of the tether dictates the maximum payload it can throw. I chose 5 tons for an earlier thing. So I will throw one container at a time at Michael.
Okay.
Michael will be up there on his lunar elevator, and his lunar elevator has a maximum capacity as well with the strength of the material. So he will take each 5-ton package and lower it down in the elevator. Over.
Yep.
So you guys, let's head towards closing this meeting. Jeffrey, you're next.
Yeah, well, first of all, for Bruce, I'd like to be around when it's done. I don't think I can wait for an elevator. Just a technical point. As a member of the board of directors of NSS, I'm very happy to have as many meetings as possible at the ISDC. But somebody will have to check with Mike Coburn to tell him to try to keep a room available of whatever size you want, whatever day you want, because in the last couple of years, there's been a high demand for spaces and a lot of people have been disappointed. So just keep that in mind as a technical matter.
Well, it would be a single presentation slot, wouldn't it, Jeffrey?
That's not what I'm
You
talking
got to
about.
talk to Mike Coburn. You probably
Oh,
want it more
no.
like a workshop, if I would think, from my point of view, rather than
That's
just a
not what I'm thinking
presentation.
is a workshop.
Presentation you can do by email. No
Okay.
reason to meet personally for that.
Yeah, I think I think a workshop is kind of a necessary, maybe not first step, but soon step, just to get people into the game.
So
Yeah, I
when
don't
is
think we
the
want to wait a
DC?
year.
No, right.
Aiden, you're next.
Have we considered advertising through the Planetary Society, or maybe some popular Discord servers, or other forms of communications for people who are in aerospace?
For this group?
For this group, yep.
Well, I posted a invite to the Discord server that I mentioned. You're welcome to use it if you join and give me, I don't know, what do we want to call the group? I mean, just indicate that you want to be on this group, and I'll set up a category that everybody in this group has access to, but not anyone else on the server. Or
Space Logistics Working Group.
Something. Okay.
Call it little boxes in the sky.
Can I do a quick screen share?
Yeah. And Eric, we will get to you.
That is not what I'm trying to share.
I have just a quick comment while he's working on that.
Yeah, go for it.
Michael, you said very intellectually, honestly, and humbly that we're not the right people. We're not qualified to make such a standard. Totally agree on that. But like when you're trying to find some information on the internet and you can't Google well and you complain about it, people just tell you a skills issue, learn how to Google better. But if instead you very, very confidently put out something wrong, then you will drive everybody to come out of their woodwork and tell you what's wrong about your idea and fix it up for you.
Love that. Love that.
So this group could just say this 2-meter cube thing is absolutely perfect. There's nothing else to consider. Boom, boom, boom. Bob's your uncle. This is the new standard. Let's go. And then have everybody else come out. Wait a minute.
Wait a minute.
This and the other thing. Oh, really? Okay, let me just write
Love
that.
that. All right. Well, what I was going to say was I took a lot of notes here. Doug, if you can give me the emails of everybody, I'll share these notes to folks and they can add in the piece that they want. And my comment that I just wrote for myself is Lane, have been dragooned into being the meeting chair for future meetings. Gooned.
Yeah. Michael, you're under protest is noted. I have a kind of a weird idea I would have 6 months ago. You might just pose a question to ChatGPT and ask them what is the ideal way to design, and you're going to hone as the questions go. You can add all sorts of variables. Nothing else, you may get ideas out of it.
Yep.
Yeah, there's loads of low-hanging fruit you can the pre-training.
One other thing. Oh, go ahead.
So can you to whomever you said rooms are at ISBC?
Mike Coburn, and that would be. Hold on a second. Just this should take me a minute to do. Not long. It's Mike dot Kobrin, Kobrin, at nss.org. I can take me longer to look on his phone number, but your first contact might be better by email.
That's fine. I say again, Mike dot Coburn,
No,
Cobrin.
Kobrin, Mike, Kobrin.
Michael, I can sit you up too. I talk with Mike Coburn all the time.
Okay, perfect. Hey, Tom, as the chair of the Center for Space Commerce and Finance, maybe this is something that the center wants to take an active role in, and we can talk about that later.
We can talk about that later. I did offer, if someone can make the business case for some of this, I offered a space on my business track at ISTC in June. So if you're reading the notes, on the side, well, we can talk about that some more. Absolutely. This is definitely material for a follow-up show. Told you I was wearing my podcast host hat as opposed to my engineering hat.
Real quick, Doug, you've got a recording of what's going. Can you make that available and post a link to that in this Discord? And reminding, the one of the principles of Discord is that people can join later and they can go back and catch up on what they've missed in the discussion. So maybe we could do that, or if I don't know if you ran the AI summary function on it, but an AI summary of the meeting would be good to post there.
Yeah, I'll go ahead and do that. Let's, I know, Jeffrey, you were sort of raising your hand, but I would like to go ahead and aim towards closing down the meeting. How urgent is it that you need to share something?
No, I had a bad joke and I decided not to say it.
You listen to that voice in the back of your head.
What you need is more inside the box thinking.
And on that fine note, I want to thank you all for participating. Man, you guys hung in there. I appreciate it. And my feeling is that this is really a good experience. I'm quite happy as a first meeting how it went, and let's continue looking up.
Right. Thanks, y'all.
All right. Take care.
Thanks for inviting me, Michael. Thanks, Doug.
You're welcome.
Nice to meet you, by the way. Sorry about the feedback.
Oh, no problem. No problem. Good to see you again. Okay, I'm hanging up.